Question number 16, a landscaping arrangement. A landscaping architect wants to create two equivalent flower beds, one rectangular and one square, as represented in the following figure. The square flower bed to be planted with shrubs has a side length of c meters. The rectangular flower bed to be planted with flowers has an area represented by the polynomial 2c squared minus 70c plus 600, and a width represented by the binomial c minus 20. The architect wants to surround both flower beds with a fence. The graph below gives the cost per meter of the fence according to the length in meters of the fence. What is the total cost of the fence surrounding the flower bed of flowers? We start off with these two, the square and the rectangle, being equivalent. The area of our rectangle is 2c squared minus 70c plus 600. I'm going to factor that, and I know one of the factors has to be c minus 20. I see that all these terms are divisible by 2, so I'm pulling out the 2, and then I'm going to pull out the c minus 20. I'm looking for the factors of 300 that add up to give me 35, where one of the factors is definitely 20. 300 divided by 20 is 15. They both have the same sign, and that sign happens to be negative. C minus 20 times C minus 15. This is the area. We know that if this width is C minus 20, the length must be 2 times c minus 15, and the width is c minus 20. The area of the square, the side length is c, so the area is c squared. We can set up an equation. We can say the area of the square is equal to the area of the rectangle. C squared is equal to 2 times c squared minus 70c plus 600, which gives me 0 is equal to c squared minus 70c plus 600. Then I can factor this. Now I'm looking for the factors of 600 that add up to give me negative 70, 60, and 10. 0 is equal to c minus 10 and times c minus 60. When c minus 10 is equal to 0, we get c is equal to 10. When c minus 60 is equal to 0, add 60 to both sides, we have c is equal to 60. Now c can't be 10 because if we're looking at c minus 20, that gives us 10 minus 20 is negative 10. You'd have a width of negative 10, which doesn't make sense. We're going to X that out. C is equal to 60. Our length is 2 times 60 minus 15, which is 2 times 45 is 90 meters. Our width would be 60, take away 20 is 40 meters. This would be 60 meters by 60 meters. The perimeter would be 2 times the length plus the width, which would be 2 times 90 plus 40, or 2 times 130, which would be 260 meters. And the perimeter of this fence would be 60 times 4, which would be 240 meters. Our total perimeter would be 260 plus 240, which is 500 meters. The graph below gives the cost per meter of the fence according to the length in meters. The more fence you have, you're going to pay less cost per meter. It's going to be cheaper the more you're buying. You're going to get a break on the price per meter. What is the total cost of the fence surrounding the bed of flowers? So I'm looking at this. I'm noticing that it's opening the opposite way. So my B is negative. The step length is negative 100. That means my B is 1 over negative 100, or negative 1 over 100. The step height is 0.25. Going up by 0.50, 0.50 up here. The step height from here to here is half of 0.5. It's going to be 0.25. B is negative, and the slope is negative. That means the A must be positive because the A times B gives us the slope. The A is positive 0.25. Then we want to look at one of these solid dots as our vertex. I'm going to take this one, which is at 100, and this is 50, at 0.5. This is 1, 2, 3, 4. This is 104 is the vertex. My A is 0.25. The B is negative 1 over 100. X minus the H is 100. Close the brackets, close the greatest integer bracket, plus the K is 4. That's my equation. We are plugging in the length of X being 500. That gives me 500 minus 100, which is 400, divided by 100 is negative 4. The greatest integer of negative 4 is negative 4 times 0.25, or a quarter of negative 4 is negative 1, plus 4 is 3. It's going to cost $3 per meter. The fence cost is $3 per meter. 3 times the number of meters, 3 times 500, is $1,500. And that's it for question number 16. Have a good day.